If you think AI only needs chips, servers, and electricity, there's one more thing you're missing. Water behind every chatbot response, every AI-generated image, and every model being trained. There are massive data centers filled with thousands, sometimes tens of thousands, of servers running around the clock, and all of those machines produce heat. A lot of heat. That heat has to go somewhere. Otherwise, those expensive chips simply can't keep running. And in many data centers, one of the most effective ways to get rid of that heat involves something incredibly ordinary: water. But here's where this story gets more interesting. Because the water being used inside the data center may not even be the biggest part of the problem. A much larger share of AI's water footprint can be hidden somewhere else entirely. At the power plants generating the electricity those data centers consume. And as America races to build AI infrastructure at a scale we've never seen before, that raises a surprisingly basic question. Does America have enough water for the AI boom? Why does a computer need water? At its core, a server is basically a machine that turns electricity into computation. But not all of that electricity becomes useful computing. A huge amount of it eventually becomes heat. Your laptop deals with this using a small fan, maybe a heat sink, maybe some passive cooling. A data center is playing the same game, just at an enormous scale. Imagine rows and rows of server racks, thousands of processors, networking equipment, storage, power systems, all running constantly. And the newest AI chips can pack an incredible amount of computing power into a very small space, which means they can also create an incredible amount of heat in a very small space. So cooling becomes critical. One common approach uses chilled water to absorb heat from inside the facility. That heat is then carried away and, in some systems, eventually reaches cooling towers. Inside those towers, some of the water evaporates. And when that water evaporates, it takes heat with it. It's basically the same principle your body uses when you sweat. Simple, effective. But when you do it 24 hours a day, at industrial scale, the amount of water involved can add up. Now, this is where we need to be careful. Not every data center uses water the same way. Not even close. Water use can depend on the climate, the type of cooling system, the efficiency of the facility, the chips inside it, how heavily those chips are being used, and even where the electricity comes from. Researchers at Lawrence Berkeley National Laboratory found that the water footprint of the same computing workload can vary by more than 10,000 times, depending on where and how that workload is run. That's an enormous difference. And it's why claims like, "One AI prompt uses this many bottles of water," can be misleading. Because there is no single number that applies everywhere. But direct water use is still growing. Even with all those differences, the overall trend is pretty clear. American data centers used roughly 65 billion liters of water directly in 2023. And by 2028, that figure could rise to somewhere between about 145 and 275 billion liters per year, depending on how quickly the industry grows and how new facilities are designed. Those numbers sound enormous. And they are. But they also need context. Take Virginia. Northern Virginia has become one of the largest data center markets in the world. In 2023, Virginia's data center industry used roughly 2.1 billion gallons of water. That sounds alarming. But it still represented less than half of 1% of all water withdrawn across the state. And more than a third of the industry's water came from reclaimed sources. That tells us something important. The problem is not necessarily that data centers are going to drain an entire state dry. The real issue is often much more local. A large facility built in a water-rich area may create relatively little pressure. Put that same facility in a dry region, or place dozens of facilities in the same area, and the equation can change very quickly. The water use you don't see. And now we get to the part of this story that's easy to miss. When people hear data center water use, they usually picture cooling towers, pipes, maybe huge tanks of water. But some of the largest water use associated with data centers may happen nowhere near the data center itself. It happens at power plants. Many types of power plants use water. Some use it to produce steam. Others use it to cool equipment. So when a data center consumes electricity, it can also indirectly depend on the water required to produce that electricity. A recent series analysis looked at 7 major data center states: Virginia, Texas, California, Illinois, Georgia, Ohio, and Arizona. Together, those states contain roughly half of America's data centers. According to the report, the electricity systems serving data centers in those states depend on around 3.4 trillion gallons of freshwater withdrawals each year. And roughly 78% of the electricity in the states they studied came from power plants that use water in their operations. Now, that does not mean data centers personally consume all 3.4 trillion gallons. That's an important distinction. The number describes the broader power systems they rely on. But it shows us why looking only at water used inside the facility can miss a huge part of the picture. A data center could dramatically reduce its on-site water consumption while still depending on electricity produced by water-intensive power plants. By 2030, Ceres estimates that electricity generation could account for as much as 72% of the total water consumption associated with U.S. data centers. And that is the hidden connection. AI needs servers. Servers need electricity. And in many parts of America, electricity needs water. What happens when AI moves into dry places? This is where things get more complicated, because water does not have the same value everywhere. 1 million gallons of water in a wet region is not the same thing as 1 million gallons in a place struggling with drought, or falling groundwater levels, or rapidly growing cities. And some of the most attractive places for new data centers happen to be in states like Texas, Arizona, and New Mexico. Why? Land, energy, tax incentives, large development sites, fast-growing economies, in some cases, supportive local governments, but water can become a real constraint. Ceres found that among the water-using power plants in the 7 states it studied, around 66% were located in areas facing medium-high to extremely high water stress. That's where a technology story can quickly become a local political story. In New Mexico, for example, debate around the massive Project Jupiter data center development has included concerns from residents and farmers about water in an already dry region. But there's another side to this. The technology itself is changing. Oracle says its updated design for Project Jupiter will use a closed-loop cooling system and will not rely on community drinking water for routine data center cooling. The company says the water used by its cooling and fuel cell systems would be needed for initial filling, with relatively small amounts required afterward. And that gets to the heart of the issue. The right question isn't, do data centers use a lot of water? The better question is, which data center? Which cooling system? In what climate? Using what water source? And powered by what kind of electricity? Those details can completely change the answer. So why not just stop using water? In some cases, you can, and companies are trying. Closed-loop cooling systems can circulate the same liquid over and over instead of constantly losing water through evaporation. Some facilities rely more heavily on air cooling. Newer liquid cooling systems can bring coolant much closer to the chips themselves, removing heat more efficiently. And reclaimed water can sometimes replace drinking quality water. All of those approaches can reduce direct water consumption. But there's a catch. There's almost always a trade-off. If you reduce evaporative cooling and rely more heavily on mechanical cooling, you may use more electricity. More electricity can mean more water use at the power plant. More sophisticated water treatment can also require more energy. Move a data center to a cooler climate, and you might reduce cooling demand. But now you may be farther from users, network infrastructure, or major energy sources. There is no single perfect design for every data center. And that's why reducing AI's water footprint isn't as simple as swapping out one cooling tower. You have to think about the entire system. The servers, the cooling, the climate, the electricity, the water source, the location. Everything is connected. And this is where AI becomes an infrastructure story. Most conversations about AI focus on technology, faster GPUs, bigger models, more capable systems, larger data centers. But every time one of those data centers gets built, it plugs into the physical world. It needs electricity, transmission lines, power plants, water, wastewater infrastructure, land, roads, construction workers, and communities willing to host it. That helps explain why data center projects are beginning to face more resistance in parts of the United States. From Nebraska to New Mexico, communities have raised questions not just about AI, but about electricity prices, water, farmland, infrastructure costs, and who actually benefits. That doesn't mean data centers are automatically bad for the communities that host them. Far from it. They can bring billions of dollars in investment, construction jobs, tax revenue and major infrastructure spending, but the benefits tend to be very visible. The costs can be harder to see, especially when those costs are spread across water systems, electric grids, and local infrastructure, and may not show up for years. So, is AI going to make America run out of water? No, that's far too simple. At the national level, data centers are not America's largest water user. Agriculture, public water systems, and other industries remain much larger. Even in Virginia, America's biggest data center hub, direct data center water use still represents a relatively small share of statewide water withdrawals. But that doesn't mean there isn't a problem, because water is local. A highly efficient data center built in the right place, using reclaimed water, with a low water cooling system, and electricity from sources that don't require much water, could have a relatively small impact. But put dozens of massive facilities in a water-stressed region, and you get a completely different story. And that's what makes the AI boom so difficult. It's happening fast, really fast. Communities are being asked to approve projects today, before anyone knows exactly how large aid demand will become 5 or 10 years from now. The bigger picture, AI feels almost invisible. You open a laptop, type a question, and a few seconds later, an answer appears. It feels like it came from nowhere, from the cloud. But the cloud isn't actually in the sky. It's sitting inside enormous buildings, on real land, connected to real power lines, using real infrastructure. And, in many cases, depending on real water. The future of AI be shaped by smarter models, faster chips, and better software. But it may also depend on things far more basic: electricity, land, and water. Because AI may live in the cloud, but the cloud still has to stay cool.